In this video, we're going to be covering a milling example inside of BobCAM for SOLIDWORKS. Now, to get started, before we can do any tool pathing, we need to start a new job. We need to tell BobCAM that we're starting a new job and what type of job we're going to be running. So to do that, I'm going to go right over here in the CAM tree tab to where it says CAM defaults. I'm going to right click. Now on CAM defaults, I could say new job. Now inside of new job, we get a choice of milling, turning, or mill turn, depending on what's on your license. In this case, we're going to go with milling. Now down here, we get to pick our machine, and there's a lot of machines built into the system already, but you might even have a custom one. So you want to look for the specific machine you want to use. I'm just going to use this generic BC3X mill, and then we're going to move on. Now to move on, you could either uncheck Start Stock Wizard and hit OK, and it'll just load the CAM tree, or we could go create our stock. So I'm going to say Start the Stock Wizard, and then this green check mark to OK it, and it's going to launch the stock wizard. Now when you get into here, it's going to ask if you want to select a workpiece, and what the workpiece represents is a final finished product. This model that represents the finished part is my workpiece. So I'm just going to select that and then hit the arrow pointing to the right, so the next button right here. Now when this loads up, we have our 6 different stock types, which you took a look at in the earlier video. And in this case, my part is not oriented the way that my UCS is set up in my coordinate system here. So I need to know that this is my Y going vertical, where I would normally call it Z, but I just need to know that so I could add a little bit of extra stock to it. So I'm going to scroll down, and right here where we have our offset for the X, Y, and Z, I'm going to go to Y positive, because the direction that this arrow is pointing in is always positive. And what I want to do is I just want to add 100,000, so just 0.1 for material that we're going to face off the top of that part. Now when we're done, we just hit next again. And this is where we get to go and pick our origin. And this is where this orientation being wrong is really going to come into play. So I want to have the part sitting like this at the machine. I want it to sit just like that. So I want to go and say pick my origin, and I'm just going to pick this top point right there. And we'll see that our X is in the correct direction, but the Z and the Y are flipped. So these boxes right down here where it says X-axis, Y-axis, and Z-axis allow us to actually go in and change the orientation of that UCS just by picking a line that represents the direction we want to point. So I'm going to say I want my Y-axis to point along this line right here. And now we'll see we're at that point. We have our X going this way, our Y going this way, and our Z going up, which means that when we cut this part, we should expect to see positive X and Y moves when we're cutting, and then negative Z moves. When we're done with that, we could scroll down and check our clearance plane. This is just an area above the part that's safe to move the tool around. 1 inch should be fine for me. Right here we have our work offset, so I'm going to use work offset number 1, or in my case it'll be G54. And then right down here we have our work offset actual offsets. So this isn't something you need to do if you don't have the Machine Simulation Pro. If you don't have the Machine Simulation Pro, you can just leave this the way it is. These numbers do not affect the G code in any way. All it's going to do is lift my part up virtually inside the simulation. So I'm just going to go ahead and lift it up 4 inches as if it was sitting on top of a tall vise. And then I'm going to hit OK. And now we have our stock created. Now before we start getting into the tool pathing, let's first go in and set up our tool crib. Now you do not have to set up a tool crib at the start by default. What you can do with the tool crib is kind of build it as you go along. But if you do that, then BobCAD picks tools that you may not want to use. So to get into the tool crib, right here in the CAM tree, I'm going to right click on milling tools and then go down to tool crib. When tool crib loads up, we can just scroll down, and I'll start by picking the first tool that I plan on using, which is going to be my center drill. So I'm going to go center drill, add from the tool library, and then I'm just going to choose my 1/2 inch 90-degree spot drill right here, and then hit OK. Now normally I would go in and pick the drills as well, but I don't need to. BobCAD will pick the drills for me based on the diameter of these holes that I select. So later on, we're going to do a cool hole recognition, and it's actually going to pick the drills for me. I'm only putting the center drill in here so that it automatically picks the center drill for me. So I don't have to go in and have it pick a number 5 or some other center drill. It's going to pick my 1/2 inch 90 degree. From here, I'm just going to scroll down to the end mill rough category, and I'm going to add from my tool library. And I'm just going to go ahead and sort by my diameter here. And I want to pick my longest 1/2 inch end mill. So right here I have a 1/2 inch flat end mill long. And it's a flute length of 2 inches. So that should be plenty to get in and clean up most of these areas already. When we're done, we can hit OK. So that 1/2 inch long will be used to do the pockets. I now have the center drill for the holes. All the holes will also have their own drill applied to them. So I need a facing tool. And I need a ball mill that I can use to clean up this part right here. So I'm just going to go in and say, let's do another end mill rough, add from the tool library. I'm going to sort by my diameter once again, but this time I'm going to click it a second time. That way I get my large tools at the top so I could see a lot of the tools I'd use for facing. And on this one, I'm just going to use a 1.5 inch insert face mill and then hit OK. Now that tool's been added in. And then the final tool we need to get is a ball mill. So I'm going to go to my end mill rough once again, and then add from the tool library. So for the ball mill, if I sort by my diameter and I scroll down to my 1/4 inch tools, we'll see we don't have a 1/4 inch ball mill. There's really only a 1/2 inch ball in here by default. So we need to make this tool. So I'm just going to go ahead and hit an add sign here. At the bottom of the list, we'll find our tool, and I'm just going to double click on it. And I'm going to type in 1/4 inch ball end mill. And then I'm going to set up my sizes. So I'm going to say my diameter is 0.25. I have a flute length of 1 inch. My corner radius is going to be 0.125, exactly half of the tool diameter. 4 flutes is fine. The overall length being 5 is fine. And then it's sticking out 2 inches, which should be plenty. The only other change I'll make is I'm going to make it a carbide tool. And since I'm already creating this tool, I'm going to go ahead and assign a tool holder as well for a 1/4 inch Cat 40 and then hit OK. Now that I'm done, I'll go ahead and hit OK again, and it's going to select that 1/4 inch ball mill. So there it is right there. So if we scroll to the top of this list over here on the left, we can go to all tools. And we can see we have a center drill. We have our 1/2 inch long roughing end mill. We have our 1.5 inch insert face mill. And we have our roughing end mill, which is really what we're going to use to finish the little 3D section of this. Now, for tool numbering, I tell people don't worry about tool numbering until the end of the job, because we can go in and just renumber everything later on. When we're done with that, we'll hit OK. Now, first, we need to face this material off. So we're going to start by right-clicking right here where it says Machine Setup 1, and I'm going to do a mill facing feature, which this one doesn't need geometry selected for it. It really just needs to see that extra stock on top of the part. So I'm just going to hit next. Right here, we'll see it's the top of feature set to 0. That's where our origin is based off of. And then our total depth is just taking off the 100 thousandths that I added in earlier. Remember that you're taking off 100 thousandths now, so every toolpath that starts after this should have a top of feature of minus 100 thousandths. We'll see that in a few minutes. Next, we have our machining strategy. And with this toolpath, all we have is facing, so we'll just say next. Right here's my posting tab, so we have our work offset number and then an output rotary angle, which could be used for 4th axis, but usually not. So we'll ignore that. And then right here we have our facing tool. So grabbed my 1/4 inch ball mill. I'm just going to go up to my tool crib, and I'm going to pick my 1.5 inch insert face mill and hit OK. And what you'll see is the tool number, even though that wasn't the first tool we added into the system, it now becomes the first tool because it's being used first. Now right down here we have our tool number, our height and diameter offsets, and then our coolant type. Over here on the right we have our feeds and speeds. So you can let BobCAM calculate the feeds and speeds, or you can go in and type in your spindle RPM, your cutting feed rate, or your plunge feed rate. And if you enter those 3 values in, those are what are actually going to show up inside the code. So we'll just go ahead and hit next. Right here we have our pattern. So how does the tool move around the part? We can go with a zigzag. We can go with a zig where everything stays moving in one direction. Or we could go with an adaptive. I'm going to go with the adaptive here. I'm going to tell it to climb mill. And I'm going to set my step over to 45%. And then hit next. Right here for the parameters, if I was trying to leave any material on the floor or really the top surface here, I could put a value in here, and that's what's going to be left for this, for maybe another finish pass to come through. But in this case, I'll leave it at 0, and I'm going to take the full 100 thousandths in one pass. So we'll go next again. For our leads, we get a choice of doing vertical leads or parallel leads, and the rule of thumb I use when I'm setting up leads is half the tool diameter. So in this case, I'll just say 0.75 for the length on both the lead in and lead out. And then right here we have our links. So if there's a gap over specifically 200% of my tool diameter, it's going to lift the tool and relink it. In my case, we won't have any of that, so we'll just hit next again. Right here we have convert rapids to feeds, and what this is used for is taking the rapid moves, the G00s, out of the program and replacing them with G01 moves with a feed rate. So you're basically using those G01 feed moves as a rapid move. And then we have our lead in and lead out feed rate percentages. So if you want to use a different feed rate when you're leading in and leading out, you can check this and tell it to use a percentage of your cutting feed rate. When we're all done and we can't hit next anymore, we'll just hit compute and give it a second to calculate. And there is our facing pass right there. Now, whenever I'm done with a toolpath, I always like to blank it out and then shrink it up. So we can right click on where it says feature mill facing and then just say blank unblank toolpath and then hit this little arrow to the left of it to shrink it up. Now, while I'm also blanking things out, I also like to hide my stock. So right here where it says the word stock, if we expand that, first we can see what material it's made out of. If we need to edit that, we can right click and say edit and change it. And this will actually update the feed rates, even for the toolpaths that we've already used, as long as we left the button checked that says use system feeds and speeds. But I'm going to leave it on aluminum, and I'm just going to right click on the word stock here and say blank unblank so I can visually hide that big piece of stock. Now from here, I could then right click and do my holes. So the next step is going to be drilling all the holes. And this is very easy in the new system because you could right click and go down to hole recognition. Inside of hole recognition, we can go in and say select hole bodies. We can pick our model. And if you need to, you could set minimum and maximum hole diameters just in case it's grabbing some things that maybe are too small for you to drill or too large. Maybe it picks up a hole that really isn't a big hole. But after we do that, we can just hit OK. Now, when we hit OK, this recognized hole features box will pop up, and it's going to read the different sizes of the holes that are inside of our job. And we can see that the top of feature here is set to minus 0.1 because we've already faced off that much material, and the total depth is 2 inches, which this part is 2 inches thick. Now, right here for the feature type, we could choose whether we're doing a hole, whether we're going to tap that hole, do a counterbore or a counterbore tap. We could also tell it it's a blind depth, and that it's chamfered if we wanted to. In my case, though, I'm just going to hit compute, and there is the toolpath for all the drilled holes. And you'll see it separates it into 2 separate features. Now, to make sure that it picked the right center drill, I want to right-click on either one of them and say Edit, and I'm just going to go right here to the center drill, and we'll see it picked my 1/2-inch 90-degree spot drill. So that's perfect. We'll just say Compute again or Finish. Either one's fine. Again, when we're done, let's go ahead and blank those out by right-clicking on them and just saying blank unblank toolpath. And there we have all our holes done already. Now we're going to go and do these 2 little pockets on the outside right here. We're just going to start by right-clicking on Machine Setup 1. I'm going to go down to Mill 2 Axis and then select Geometry. And I'm just going to pick the floor of both of those pockets right there. From here, I'll just hit OK and then hit Next. Right here, we'll see the top of feature again shows up as a minus 0.1, which is perfect. We have our total depth at 3/4 of an inch. And if we wanted to make sure it's actually 3/4 of an inch, we could say pick bottom and just pick a bottom edge of that part and then hit OK to verify that that is correct. From here, we'll go next. We have our machining strategy where we could choose pocketing, which pocketing gives us a pocket and a profile finish pass. So it's always going to give us a finish pass afterwards. And we'll hit next. Right here, we're not going to leave any tabs on a pocket. Tabs are areas of the stock that stay connected as you cut your way around a part so that the part doesn't drop out when it's freed up. We don't need that on this pocket, especially since it's not even a through pocket, so we'll go next again. Right here's our posting tab, so we're using work offset 1, no output rotary angle, and the contour ramping I'm going to leave on arc moves. From here I'll go next. We have our 1/4 inch ball selected. We're just going to go to the tool crib, and we're going to pick our 1/2 inch flat end mill long, and then hit OK. After that we'll just go next. Right, here's our patterns. Now there's 2 different types of patterns that you could run. There's standard pockets and there's advanced pockets. And then there's a breakdown of patterns inside each one of those. A standard pocket is never allowed to leave the part. An advanced pocket does have the ability to leave a part to do open pocketing. But in this case, they're both closed pockets. There's no opening, so we could use either one. I'm going to go ahead and use an advanced pocket with just an offset pocket out. Right down here, I'll choose climb mill. We're not going to change the rest roughing at all. And I'm just going to set my step over to, let's say, 30%. From here, we'll go next. For the parameters, this is the amount of allowance that's going to be left on this part. So on each wall, I'm going to leave 15 thousandths. And that's all the finish tool is going to go in and clean up. So I'll leave 15 thousandths there. And then right down here, we have our depth. So we could either do this as a single step where we do one pass and take the full 3/4 of an inch out at one time, or we do multiple steps, and I'm able to come in and say, let's do a 1/4 inch per pass. So we should have 3 passes to get down to the bottom of that. From here, we'll go next. This is our leads, or how we enter into the material. And in this case, I'm going to go ahead and do a ramp with this one. And the length or radius, it's just the length really. The radius is for the spiral down here. But I'm going to go with a length of just a 1/4 of an inch and an angle of approach at 5 degrees. So it's going to angle down 5 degrees and just move back and forth along this 1/4 inch till it gets to its depth. Next, we then have our machine sequencing. We're only cutting 2 pockets here, so it's not that big of a deal, but you can go closest. You can go with no sorting, which actually picks the order that you picked your geometry in. That's the way it's going to run. You could sort by your X direction, so everything along the X or the Y, or you could set up a custom direction. Or the one that I primarily use is optimized, because it's going to pick either closest, no sorting, X direction, and Y direction. Pick the most efficient one for us. So I'll go next again. For the links, just how do we connect from one pass to the next? We can go direct, we can make an S link, or we can full retract and rapid. I'm going to go with a direct, and then between any groups, I'm going to go with direct. We shouldn't have any groups in here, so we'll go next again. Right, here's our advanced feed rate. So we have our convert rapids to feeds, just like the other facing toolpath. We have our linking feed rate, so it's the feed rate that's used when we're linking. And then we have some adaptive feed rates. Now, if you're using a high-speed machining strategy, you'll actually get more options than just this to do real high-speed machining. Right over here, we have our corner slowdown, and the corner slowdown allows us to slow down as we encounter a corner defined by a certain distance, so we can get a nice clean cut around that corner. Next, again, we have our profile finish. Now, the profile finish, I'm going to use the same tool. So I'm going to go to Tool Crib. I'm going to pick my 1/2 inch flat rough end mill long, and then hit OK. From here, I'll go next. On the patterns page, we only have one pattern to follow with a finish pass, but right down here we have compensation. So this allows us to compensate for the tool and add a G41 into the code. So not only is the system automatically going to compensate the 1/4 inch that this tool needs to move over so that the edge of the tool is running along the wall, we can also add a G41 into the code so that we can compensate for that as we run. Now, because the tool's already being compensated for, we can use a small lead-in for this, because it's during the lead-in move that your machine is actually going to apply the compensation. So when we hit next, we have our parameters, which this one's not really going to change. It's a finish pass, so we're not leaving any allowance, and we're just going to take out the 15 thousandths that's on the wall at the full 3/4 of an inch depth. So we'll go next again. Right here we have our lead, so this one will plunge in, but on this we can use a lead in. I'm going to go ahead and do a circular lead in, and I'm just going to set these to a 1/16 of an inch for the length. and a 1/16 of an inch for the radius. And then I'm going to hit next. Right here for the corner types, we're not going to make any changes to this. I don't even have any sharp corners in this cut. I'm just going to leave it on sharp, and it's just going to follow the geometry. Nothing to change there. Machine sequencing, once again, we'll turn it to optimized. And then right here's our advanced feed. So we have our convert rapids, our lead in and lead out feed rate percentages, and then our corner slowdown. When we're all done, we can go ahead and hit compute. Now, when that's all done, we can actually rotate this and see we have multiple passes, and then there is our tiny little finish pass right down there. Now, we can move where the start point is. If we don't like where the start point's at, we can actually right-click on where it says Default Chain Start Point and say Modify, and I could say I want it in the middle of that one and the middle of this one over here, and then hit OK, and then just right-click on the Feature 2 axis and recompute the toolpath, and that's just going to move those leads to a different location. And looking at this, I could probably go with a bigger lead in, but this should work fine because the tool's already compensated for. So now I'm going to right click on that feature 2 axis, say blank unblank toolpath, and then shrink it up. Now for this big inside pocket, we can actually use the pocketing feature that we already created. The only difference is this pocket's deeper. So if I right click on this feature 2 axis, I can go down and say copy, and then right-click on Machine Setup 1 and Paste Feature. Now, it'll ask me if I want to use the same top of feature and depth values, and I'm going to say yes. I do want it to remember what top of part we used, but the depth I'll repick here in a second. So over here where we have our Feature 2 axis, our new one, which doesn't have the eyeball on it, and you can actually rename these features. You can right-click on them and say Rename, but I'll remember it, and you can also click on them just to show you what feature it is. So for this one, we have to go pick new geometry, and that's what this little red plus sign represents. So I'm just going to right-click on geometry and say reselect, and then I'm going to go and pick just the floor right there. So it's not reading that fillet, it's just reading the outside there all the way around, and then we can hit OK. Now when we're done with that geometry selection, we can then right-click and say Edit on that newest feature. We'll say Pick Bottom, and just make sure that it picks the bottom. It looks like it was right. It was already at 1.25. All the rest of the settings, like my depth of cut, should work just fine. So I'm just going to hit compute and wait for it to calculate, and there is our center pocket. Now after that's done, we're going to blank it out and shrink it up. And finally, we just need to finish this inside ledge right here. So we're going to do that using a 3-axis Z-level finish toolpath, which is good at cutting walls. So we're going to right-click on Machine Setup 1 and go down to Mill 3-axis. And then we're going to select our geometry, and we're going to say select whole bodies right there, and we're going to pick the entire model. And then when we're done, we can hit OK. And then for here, we're going to go ahead and select our boundary, and all I'm going to do is pick this boundary around the outside all the way around this hex. So that, all the way around. Let me zoom out right there. And finally right there. So we have all of those pieces selected to tell BobCAD that that is where the toolpath is going to go. When we're all done, we'll hit OK and then go next. Right here we have our top of feature set to 0. Really the top of feature is at minus 0.1. So I'll leave it right there and go next. Right here for the strategy. Now if you have the standard toolpaths and the pro toolpaths, you could use a bunch of different toolpaths to cut this area. The most efficient would be a toolpath that focuses on cutting the walls, which the Z-level finish does. If you have the Pro toolpath, you could also use the advanced Z-level finish. But in this case, we're going to just use the Z-level finish and then go next. Now for posting, we're going to make sure to click Arc Fit. That's going to make sure that we get arcs inside of our G-code program. Next again, we have our 1/4-inch ball mill, which is finally the right tool to be used. So we'll go ahead and hit next again. For the patterns, we're going to leave it on climb mill. Next, the parameters. How much are we going to take off per pass and leave the type of finish we want? So how good of a finish do we want? Well, the smaller number we make the depth of cut, the better finish we're going to get. So I'm just going to put this at 0.01, just a 10th depth of cut. Allowance is at 0, so we finish everything to size. Because I picked a boundary, we don't have any holes that we really need to worry about, so we don't have to worry about cutting or ignoring holes. And the top of job and bottom of job is fine. So We've already limited it. It can see the floor. It doesn't need us to set up a top or bottom. For the leads, I'm just going to plunge in with a single depth, so it just plunges in. It should plunge in and just cut fine, so we'll go next again. Right here for our options, we're going to cut everything, not the inner or outermost. We're just going to cut it all. We're going to process by area, and we're going to calculate from the tool tip, not the tool center. Right here for our links, the way that we're going to connect from one pass to the next is just by following the surface, but we could also do horizontal and vertical steps, spirals, retracts, or S-links. And then if we run into our boundary, we could either follow it around or retract and rapid back to the beginning of a cut. In my case, I'm going to go with follow and then next again. For the advanced feeds, we have our convert rapid to feed and our lead in and lead out feed rate percentages. And when we can't hit next anymore, we're just going to hit compute. And we're going to let it calculate. And there is our finish pass right there. Now we're going to look at this part inside the simulation in the simulation video later on. So that's it for this one. We've done our holes, we've done our pockets, we've done our 3-axis machining on there. And that concludes the video on the mill example from inside of BobCAM for SolidWorks.